Hey guys, today we were talking about 2.1 quadratics in vertex form. Textbook calls this transformations of quadratics, but really we've already spent some time on transformations, so I just want to focus in on that vertex form and how we handle graphing those. So for our notes here, I'm go through them again briefly just to remind ourselves. Quadratics, we know that's just x squared is my equation, that's the family. My parent graph is still that parabola. I've got my key points listed down here, but that's really, again, just my vertex at 0, 0, up 1 over 1, up 3 over 1, up 5 over 1. That 1, 3, 5 shortcut is my regular quadratic equation. So we know that any kind of manipulation x squared is just going to be a transformation of it, which is really the first thing that we're going to do to focus in on how to graph those different forms of quadratics, is using and utilizing those different transformations. So you can see here, and I'm going to highlight it right here in yellow, this is vertex form. So what vertex form is doing is it's giving us the vertex, as you would expect from an equation titled the vertex form. And it's just taking those different transformations we talked about last chapter and putting them together into just one single formula. So in this, you've got three different numbers that affect your graph: A, H, and K. Your A value, which is out front here, that tells you which direction your parabola opens and then whether it's been stretched or shrunk. Right? Because if in our multiplication process, if that A value is negative, we know that opens down. If that A value is positive, that stayed opening up. It's the same thing we had last chapter. If that A value that you're multiplying by is a big number, it's going to stretch it out, so it's going to make your parabola taller than what it usually is. So in that case, you're going to multiply that 135 by A. And if your A value is smaller, so if it's a half or a third, you're going to be multiplying it by a third, and it's going to make it shorter than what it usually is. Your H and your K, that's just adjusting your shifts. So we know a horizontal shift is adding or subtracting on the inside, and a vertical shift is adding or subtracting on the outside. So H here, that's subtracting on the inside, tells you how far to the right or left it was shifted. And the plus K on the outside tells you how far up and down it was shifted. Now, with this, the reason it's called vertex form is because my vertex for this is at H, comma, K. Because in this case, on the inside, remember, we're subtracting, so you have to be careful with that one. So if we have like x minus 2 parentheses squared plus 1, your vertex would be 2 comma 1, because that minus 2 on the inside actually shifts it to the right too. But that's pretty much it. I mean, you can read some of the tips here if you want to pause it and read through stuff, but really it's just going through and utilizing those transformations again. So what I want to do, instead of just going through and doing more talking, I just want to do a couple example problems. I chose two problems that are not your homework tonight / today, depending on when you're watching this, but still are similar to ones we have to do, because your homework for this section is page 52, 4 through 18, and 26 through 30 evens. So I wanted to do something like number 11, which is similar to 4 through 12, and then something like 24 that's more similar to 26 through 30. With both of these, your instructions are describe the transformation from f of x being x squared, so my parent function, to the g that we're given, and then graph each of those two functions. So let's go ahead and just jump into number 11 here. For number 11, we have g of x equals x minus 7 parentheses squared plus 1. So this tells me, since I'm subtracting on the inside, that's shifting it to the right by 7. And adding on the outside tells me I'm shifting up 1. So you can clean that up a little bit if you want to and say that it's a horizontal translation right 7 and a vertical translation up 1. But as long as you say that it was shifted right 7 and up 1, I'm good with that. So from here, if I'm going to go ahead and just graph some of these, I'm going to start with my parent function. parent function being 0, 0, up 1 over 1, up 1, 2, 3 over 1. So I'm going to go 1, 2, 3, 4, 5 over 1 to go a little, just get a little crazy, right? What's the harm in going a little crazy sometimes? Notice here, I am not super concerned with cleanliness in this case. For me, as long as you make an attempt at going through the points you're supposed to go through, but more importantly, as long as you have those points labeled, or at least, drawn in there so I can see what your points are supposed to be, that's good with me. All right, so for the actual graph of it, I'm going to use blue for g of x. So here now all we're doing is having to shift it to the right 7 and up 1. Ooh, sorry. So over 1, 2, 3, 4, 5, 6, 7, up 1. This point right here is my new vertex. This is at 7, 1. Which makes sense because it's shifted right 7 and up 1 from the origin, which, again, that is h, k. Right, this would be my h, this would be my k. My vertex is at hk. Since I'm not stretching at all or shrinking or reflecting, once you find that new vertex, you can really just do your shortcut up 1 over 1, up 1, 2, 3 over 1, up 1, 2, 3, 4, 5 over 1. Same thing over there to get all of your points. And then just do your best to do a nice smooth curve, connecting all those points. And that's it. You've got your parent graph, cha-ching. You've got your resulting graph, cha-ching. And we've got the description. All 3 elements of what we need. Okay, let's try one more. Number 24, a little more complicated. For number 24, we're given g of x is 1/2 parenthesis x minus 1 parenthesis squared. In this one, my instructions are actually the same, so I'm still describing the transformation f of x equaling x squared, represented by g, and then graph the function. So with this, I can just see that it's still going to be shifted to the right 1. Right, so that minus 1 tells me it's to the right 1. But this 1/2 tells me it's a vertical shrink times 1/2. So all of my y values are getting half as tall as what they usually are. So let's start with just my parent graph. I'm going to try and make this one a little bit cleaner because we're going to have to for, let's do this. Let's get fancy. Oh, I can even, oh, this is happening. Check that out. Let's move that over a little bit here. Okay. So I'm going to use black from a parent graph. We know, again, 0, 0, up 1 over 1, up 1, 2, 3 over 1, up 1, 2, 3, 4, 5 over 1. So now, go away. Come on, go on. So now, again, just try and make a nice smooth curve. Beautiful. That's my parent graph. So now, for my resulting function, I know I'm going to shift it to the right 1. So this point right here that I'm coloring in blue is my new origin, or my new vertex. But for my y values, since I'm shrinking it vertically, what my original shortcut was, and I'm going to do this in black again. So my regular shortcut is up 1 over 1, up 3 over 1, up 5 over 1. Right, that 1, 3, 5 shortcut. If I'm multiplying all those by 1/2, I end up with 1/2, 3 over 2, or 1.5, and 5 over 2, which is 2.5. So those are my new y values. Instead of going up 1 over 1, up 3 over 1, up 5 over 1, I'm going up 1/2 over 1, up 1.5 over 1, up 2.5 over 1. I'm just taking that multiplier, that stretch or that shrink, and multiplying those vertical changes by that number. So here, I'm going to go from my vertex from 1, 0. I'm going to go up a half and over 1 on both sides. Because again, instead of going up 1 over 1, I'm just going to go up a half as much. Next one, I'm going up 1.5 over 1. So 1.5 over 1 would be right here. And right here. And then the next one, from those 2 points, I'm going up 2.5 over 1, which would be right here. 1, 2.5 would be right here. And those are my 5 points. 6 points, actually. 7 points. Sorry, I can't count. So here. Beautiful. Beautiful. So that's my g of x. That was the equation I was given. This is my parent graph, f of x. And then again, we included that description of the transformations. The only thing is a little bit different on 28. What are you guys going to? On 28 and 30, they're asking you to describe the transformation, which again, that's all just kind of from the equation, and then just identify where the vertex happens. So that I think actually a little bit easier, because then all you have to do is really figure out how it was shifted, because stretching, shrinking, and reflecting does not affect where your vertex happens. It only affects the shape and the direction of that parabola. So that's the only difference between 28 and 30. 28 and 30, you do not have to actually graph it. You just need to tell me what the description is, and then what's my vertex. So that's all I got for you. Try and keep it short and sweet. If you have any questions, as always, feel free to let me know. Feel free to log back in if it's still during the class period, and you can ask questions now. Log in during office hours. That link is on Classroom under the Important Information tab, or shoot me an email and we'll find a time to sit down and work together and figure out whatever it is that you have questions on. Have a fantastic day, and I will see you guys later.